directory to extract it to. I'll show you. Um, it's really important that you remember where you save it. So for example, I can save into documents um, and maybe robotics, right? And then I would have to make sure that I remember where I save it. Okay, that's basically it for what you have to install. Just remember there's three things: Webots, Python, and the GitHub. So, and if you ever get lost, you can always check the description right here is a pretty good tutorial on how to download the first two things. All right, and Julian's now going to talk about, give a little demo in Webots.
Oh yeah, so I'll talk about the Webots environment briefly now. So here's our sample world where we have like our robot and then the rescue line course. And okay, so you see that we have like a few windows here. This is gonna be the main window where you actually can be able to visualize the robot run, right? So here we have our entire rescue line course, and then we have our robot right here. So in terms of how to like navigate through the space, if you click down and then drag with your other finger, that's gonna allow you to rotate the field. And then if you double click and drag, that's gonna allow you to pan the field. Yeah, so you can see that this world is composed of various objects, right? So we have like our robot here, and then we have like obstacles and then walls. So in terms of where all these objects are represented, you can look at this sidebar right here. And this is what we call the scene tree. So this is going to contain all the objects in our field. Um, so like all the checkpoints are described here in this block. All the tiles are described here, and then objects is going to contain our obstacles and then walls. But mostly what you guys will need to use is the definition of the robot, which can be found here. So def player 0 robot. And this is important because it's going to allow you to figure out what sensors are on the robot, and it's going to let you modify what sensors you're currently using. So if you hit this drop-down menu here, and then you go under children and extension slot and then children again, then you can see all the sensors that are currently on the robot. So in this case, we have 2 distance sensors and 3 power sensors. So you can kind of visually see them on the robot. Like here, the 3 color sensors are right here. Yeah. And then when you start programming, this will be important later, but this is also where you can find the name of all the sensors. Yeah, so to create a new sensor, you can double click or left click on children and then click on add new. And then that's gonna allow you to add new base nodes. Yeah. So like here you can add a light sensor. Yeah, so that's how you can add new sensors to your robot. What else? Yeah, so that's like a brief overview of the Webots Robot Simulator.
All right, so I'll briefly go over some of the features we implemented for in terms of the game and scoring. So as Julian showed, there's a variety of scoring elements that we added, and we do plan on adding future scoring elements. So right now we have things like obstacles, green intersections, gaps, which if you have ever done Rescue Line, you already be familiar with. We're also looking to add the newer elements like the seesaw and things like that. So for scoring, we added a HTML robot window. So you can access that by looking at your scene tree for Game Supervisor, and then right-clicking on it and saying Show Robot Window. So this is going to pull up a really simple HTML scoring page. This is the intention of this was to mirror the competition scoring sheets. So at competition, usually the judges will have a scoring sheet to keep track of what you score. So currently, this is a work in progress in terms of what we've added and how it looks and beautifying the UI. But essentially, the idea is to keep track of what you score, etc. You should be able to add, remove game elements. And once again, this is more for the judges once we actually get into competition, but it can also be used for you guys to score your own runs. Additionally to that, we have implemented a checkpoint system similar to the actual Webots Rescue Line. So if your robot ever gets stuck somewhere or it misses like a green intersection and is now going down the wrong path, normally you would call kind of like a lack of progress in that situation, right? So, and then you would be reverted to the last checkpoint. Same thing goes for that. We have an automated lack of progress system. So if your robot is, say, running and you click lack of progress, you're going to return to the latest checkpoint. In that case, since your beginning is a checkpoint, technically, then you return to the beginning. The checkpoints are marked with these yellow markers right here. So that tile is a checkpoint tile. So if we were to move our robot onto here and then hit lack of progress, then we would revert back to that specific checkpoint and etc. for all the other checkpoints as well. So this automated checkpoint system should place you back in the correct orientation going into the tile. And all right, with checkpoints done, we also included two C++ sample controllers to get you beginner started. Webots does support a variety of programming languages for robot controllers, including C++, C, Python, Java, and of course our extension for block programming, Webots Blockly. But we are officially going to include C++ samples to help you guys along. So technically you do have the option of choosing whatever language you want to use, but we always stick to C++ and block programming. So included in this world are currently two beginner line tracing controller samples. So one is essentially a regular version and another one is a PID version of that. So if I go to the controller directory, which lists all the controllers, you'll notice there's an example line tracing controller, and then there's an example line tracing controller PID. So this is just the PID version of that one. It's slightly more advanced, but both of them are really simple in that they only perform line tracing and nothing else. They don't perform intersection or obstacle. They're just for line tracing. So a quick walkthrough through what the sample code we have. And this is the Webots text editor. It has a built-in integrated text editor that you can find. If you can't find it, you can go to under Tools and click on Text Editor. And this is essentially what you're going to use to build your programs because it has an integrated like build button. So a quick rundown. The most important things to note that may be confusing for new people is the color sensors are implemented in this case as cameras. So they're essentially very low resolution cameras that allow for getting the RGB values of our camera. So instead of color sensors, we're just going to use cameras. So here's a list of the Webots includes. We also have includes for printing. So we have two color sensors currently being retrieved from this robot. We do technically have three. The middle front one is not being used, as well as two motors. And essentially the most important thing is down here inside of this time step loop. So once again, we have a lot of tutorials released online already for robot controller programming, this will just be a quick rundown of an overview of what is available here. So in this case, for line tracing, it's very simple. Essentially, we just say if the left color sensor sees black and the right sees white, then we point to the left to try to get back on the line, and vice versa. Otherwise, if neither of those conditions are met, we just move forward. So to use these example controllers, all you have to do is reset the world, and under the player 0 robot, as Julian showed you guys, where you add the sensors and everything, there is a controller field as well. So this controller field by default might be set to something other than one of the samples you're trying to run. So you might have to go under here and select the appropriate controller. So if I wanted to run the example line tracing controller, I just find it under here and click on that. And then I can run the world. Yeah, and that would just line trace around the map, but it doesn't do green intersections. So of course it can't really get past here because there is a 180-degree turn. All right, so with that said, Jeffrey, I think, is going into the Blockly programming interface.
Yeah, so as Victor mentioned before, Webots supports a lot of text-based languages, the main of which being C++, Python, and Java. But we know some of you are more familiar with, for example, graphical robot C, or just like the NXT programming, the drag and drop programming. So we've added in drag and drop programming into Webots for you. And to actually use it, you're going to go back to the scene tree. You're going to find this def Blockly supervisor robot. And the name of our drag and drop is called Blockly because, yeah, and the name of it is called Blockly. So that's how you remember which bullet point you want to go to. So you go to the Blockly supervisor, you hit right click, and then you press show robot window. And then you'll see this environment pop up. And this is where you can drag and drop. It should be pretty familiar for those of you who have used like graphical robots C before. You have a bunch of categories where you can grab different types of blocks. So under here, you have all the math blocks, you have the sensor blocks, you have delays and time here, etc. You can familiarize yourself with this as you go down. And yeah, basically here you can start, writing a program and all that kind of good stuff. And then here we have three pretty important buttons that you can use. So this submit button basically downloads your program onto the robot. This save button saves your robot. And this restore button allows you to open other files that you've saved. So for example, I can rename my file to, let's say, test1. And then I can save it. And then from here, you can see that when I hit restore, test1 now appears as an openable file, right? And when you download it, there's also a Blockly sample file for line tracing. It's just a really simple zigzag, go back and forth line tracing program, but it introduces you to the basics. So one important thing is always start with the start block. These two set up your motors. These right here are the name of your motors. Initialize the color sensor, loop, if statement, all that kind of good stuff. And again, like we just said before, we have a lot of tutorials already released on how to program in both Blockly and C++ and Python. And just to reiterate myself, if you go to the GitHub repository, which again is accessible through the website through this third link, and you scroll all the way down to the README, there's basically all the links that you need are down here. So the video is here. Another interacting with Webots video is here. Here's a Blockly tutorial. It goes through basically all the information you'll need to program with Blockly. Here's the full documentation. So in case you feel pretty comfortable with reading more advanced documents, this is a detailed list of all the features. And then for C++ and Python, we have a motors and sensors tutorial. One thing to note was these tutorials were created for a different competition. So the field may look different, but all the concepts talked about in there are still the same. They apply to this competition because you're still using motors and sensors. And then we have the Webots documentation, which leads to the Webots website. And so for those of you using C++ and Python, it's covered in here. Java is not like explicitly covered in here, but you can still watch it because literally the only difference are the names of the function calls. All the concepts behind setting up motors, probing sensors, all that kind of stuff. It's still the same between all three languages. Okay, with that being said, one last thing I do want to mention is if you are using Webots Blockly, one very important thing to remember is you need to make sure that your robot is actually linked to the Blockly environment. And we're going to go to where Victor was talking about before. We're going to hit the drop down on our player robot. And then we're going to scroll down and find the controller bullet point. And if you want to be using Blockly, you have to make sure that your controller, if I hit select down here, you have to make sure that it's set to my controller, my_controller. If it's not set to my controller, then every time you submit your program, it's not going to be submitted to this robot. So you have to make sure that your controller is set to my controller, hit OK. And then from there, you can just save your world using the Save World button. And I just want to briefly mention that when you download the GitHub repository, there's a set of folders that you need to interact with, the main of which being the worlds folder. So the worlds folder is where all your worlds are going to be saved. Right now, this full world is sample world. So if you double click on sample world, it should open up Webots by default and show you the world that you see in front of you. The rest of these worlds are like pretty mini worlds that isolate specific aspects of the competition. So for example, intersections with green, intersections without green, obstacles, a simple line tracing, and then the zigzags. So yeah, testing in each individual world allows you to test different components of your code. So you can program one aspect by one aspect, and then you can merge them all together. So that should be helpful. So this is the worlds folder. It contains all your worlds. The next one you should know of is the controllers folder. So for those of you using Blockly, the drag and drop programming, all your files, when you hit save, are going to be saved under here. Now, when you open it, it's not going to be very understandable. But let's say you need to send a file. If you take a file here, copy it, email it to maybe a buddy, and they paste it under Blockly programs, then they'll be able to restore and find your file under here. So those are for Blockly people. Otherwise, every time you create a new controller for text-based language people, a folder should be created under here, if you're using C++, that is. So yeah, under here, it'll include like makefile and your C++ program. So yeah, and then under here, you have some documentation. So yeah, here's a scoring sheet in case you need like a specific pictures to all this stuff. So yeah, but the main folders that you're going to work with are worlds and controllers. All right, so now I'm going to turn it over to Julian to talk about how to actually generate your own custom worlds.
Yeah, so Jeffrey started by talking about a few of the folders, and I'll talk about a couple more. So we also built in a feature where you can generate your own worlds to test your robot. So to access that feature, you need to go to the line generator folder. So you double click on that. And then there's going to be two different scripts you can use here. We'll start with the line generator script. So you can double click on the script to start running it, and it should open up like a terminal window. And you can follow the instructions in this window to kind of start creating your own sample worlds. So let's just create a simple 2x2 world. And then, so when you name the world here, that's going to be the name of the world when you go to the Webots line folder and then your worlds. Okay, so if we name this like test2, then it's going to save this world in this folder under the name test2. And then you also need to specify a second file which is going to create a map based on your inputs. And I'll describe this map a bit more later. Let's also call this map test2. So after you specify the world name and map name, and it's going to create the world as you can see here. And then you can fill in what objects that you actually want to put in the world. So the first thing you need to do is you need to set up all the tiles in the world, right? So one by one, you select the tile that you want to use, and then you put in the tile's orientation. So to find all the tiles that you have access to, you can go to the tiles folder. And this tiles folder is gonna basically give you the name of all the tiles that we currently have. So you basically enter the image number. So let's just say we want to use this tile here. So we would enter a 1, and then you can enter the orientation. So the default orientation is north. If you want to rotate the tile, you can use east, south, or west. And then you would continue this through for all the tiles. I'm just creating like not a real world right now. But after you enter all the tiles, then you can specify checkpoints too. So let's say we want 1 checkpoint, and you can specify the tile number for that checkpoint. Here we are giving you both the tile number and the coordinate location where the tile will show up. So 0, 0 is going to be the top left-hand corner. 0, 1 is going to be 1 tile to the right, and so on. So in this case, let's say we want to put a checkpoint in like tile 3. Yeah, and then, so this is going to be based on the actual course you can create, but it's pretty self-explanatory, like what input fields that you need to enter. I'm not going to create that right now, but basically once you fill in all those fields, then if you go to worlds and then select on your test, I'll select on one I created like previously, but that should create a new world for you with the map that you specified in the tile creation Python script. So this is going to be a really simple 2x2 world. Yeah, so this is like a simple 2x2 world that was created using the line generator. And the one other feature is that once you create a world, right? I mentioned that you create both a world and a map. So the world is going to be stored in your worlds folder, but you're also going to have a map that's stored in line generator and then maps. So to create this world, I entered test as the name of the map. So if we open up this test map, then we can see that this is going to store the location and orientations of all our tiles. This is like a description of the formatting that you can read later. But the good thing about this is, let's just say you want to change like a single tile here, right? And instead of rerunning the entire line generator script, what you can do is you can modify like any tiles in this text file. And then after you modify the tiles, instead of running the normal line generator, you can run this separate script that's called line generator from map. And then all you have to do is enter the name of the map and then the name of the world you want to create. And then this is going to create a new world based on your map. So yeah, so those are 2 scripts that you can use to start creating your own fields. And now I think Jeffrey's going to give a demo on Webots.
Yeah, so as you can see, we have a lot of scoring elements in here. There's intersections and all the normal stuff you would find in a rescue line. So we've written a brief controller. It's definitely not perfect, but hopefully it gives you an idea of what you have to do. So it's line tracing forward and all that. Skips intersection because the green is on the other side of the line. Goes over a speed bump. Oh, and one thing I should briefly mention, you're gonna see some red text here. When you first open the world, that's fine. You can basically ignore it. Those are just some messages. that Webots likes to warn you with. All right, so you see the double intersection. So it's come back around. Sees the right green. '90s are a bit not the greatest, but yeah, you get the idea. It messed up there, but you still get the idea. And then now we enter a checkpoint. So yeah, if we wanted to, like Victor demonstrated before, if we open up the game window by going to the game supervisor, right click show robot window, I could hit like a progress and hopefully it will bring it back. Yep. So you can see that it yanked it back to when it first entered the checkpoint. I can keep yanking it back. All right, so that's a brief little demo of what you need to do. So now Victor is going to talk a little bit about the plan for the future and updates.
All right, so this was just the first release of the Webots line. So as Jeffrey said, you can access our GitHub here, and you can either download our repository by coming in here and hitting download zip. I'd say that works best if you're using Windows. Otherwise, we also have releases for Mac and Linux that we specifically built for Mac and Linux. So these include the precompiled binaries and supervisors for these platforms. So if you go down, you'll have a Windows one, Linux, and then a Mac one. All right, but if you're just using Windows, like most of you probably are, it's perfectly fine to also just come here and download zip. So talking in terms of future features and improvements, we'll constantly be releasing new versions of Webots line, and these will all be posted here into our GitHub under the releases section as well. And in terms of what we're looking to do, of course, we want to include all the game elements and also the rescue zone. So that boxed area in the back left corner, that was the rescue zone. In addition to improving things like the UI of the map generator and allowing for robot customization for teams, so you're not limited to the default robot, which is like the Pioneer 3DX. So this will allow teams or people to essentially design their own robots and add more variety into the game. So that's pretty much it in terms of what we have for the meeting. So at this point, we will be taking any questions or anything you guys want us to revisit that we've seen in the meeting. So I think you guys can just ask your questions into the chat and we'll respond to that.
Pranav, is your robot still not moving?
No, I think I got it to work.
Okay. If there are any questions or you want to like sit there and think, we could probably go through and show how to like get started, like open up the world, start a new robot controller and all that stuff.
Yeah, can you show us like the steps of like, I kind of missed the first part. I'm not sure if you showed this already, but can you show like the part where you just kind of like download and then we like where we start actually going into the
Yeah, absolutely. So are you planning on using C++ or the drag and drop program?
C++.
Okay. So installation wise, there are three main things that you have to download. The first thing is Webots itself. You hit the drop down and then click on the Windows installer. I'm assuming you're on Windows, but you click on whichever installer is for you. And then after you click on it, I'm not going to download it here because it takes a while to download and run. But if you go into the downloads, you can double click on it and it will run. Let me see if I can find it. But oh yeah, here we go. So it looks sort of like this. This Webots 2021A setup, and you just run that. And then from there, you just follow a few steps. So I already have it installed, but you just follow a few steps. They're pretty simple. You just basically spam next. So yeah, that's Webots. For Python, you can just download Python 3.9. That should work. Or if you, this is built on 3.8.6. So if you just want to be like extra safe, once again, this, if you click on it, and actually, for those of you who don't know which one to download, you probably want the executable installer, x86-64 executable installer. So once you click on this, it will again download a similar thing. It'll download a Python installer. So you should just double click on the Python installer and you just follow the steps. One thing that's very important. You need to add Python to path. And if you go back, if you follow the, so you can find it. Here we go. So in this description, there's another link on how to download Webots and Python. And you should probably follow this for at least doing Python. Because you have to add Python to path, which is just letting your computer know where Python is saved. So yeah, in here, it'll tell you, it'll like emphasize. So let me see if I can find it. Here we go. So for this window, it's really important that you click this checkbox right here. This add Python 3.8 to path. It's really important that you click this checkbox. Yeah, so your computer actually knows where to find Python. So yeah, when you download this stuff, maybe it is a good idea just to follow the video along.
Okay.
Yeah, and then from there, if you go to the GitHub, which is also, remember, everything's in the description.
Okay.
And you go to the GitHub. If you're on Windows, or if you want, you can go to the release, which is probably like the safest. And you just click on whichever zip you want. So for Windows, I'm going to download this zip. And then like we said before, when it finishes downloading, you can extract it into whatever folder you want.
Okay.
Good. Any other questions?
Wait, so I still have to download the Python one. So I have to download the first the Webots, and then I have to download Python as well.
Yes, yeah. So yeah, that's a good question. Even though you're using C++, the world itself, like the backend, runs on Python. So you still need Python. Yeah, good question. All right. Anyone else? Yeah. So if you guys didn't see, there's a form inside the chat to ask us stuff and give feedback. So there's a question, would it be the same for block coding? Yes, for block coding, you still have to download all three things. It's just that when you open up the world, you can just open up the window like we said before, which again covered in the YouTube video. So any other questions? Ask now, or you still can.
Are the the goals and like instructions on like what to do, like what the robot can do listed inside the site?
So there aren't any official rules, but you can go through the like physical rescue line, like the real world, not the simulation, the real world rules. And basically we're using those rules inside of this with some little changes, but for the most part, it's basically the same thing. You need to line trace, navigate the intersections, and then get around the obstacles, all that kind of stuff. Is there anything like in specific that you're thinking about?
Yeah, and also is the map, do I have to make it, or like is there another like
There's a bunch of maps in there by default that you can just pull up. So real quick, since why not? Again, when you download it, after you extract it, it should look something like this. You have a bunch of folders. If you go into the worlds, this is where you start up. So like for those of you just starting up, after you extract it, the next step would be to go into the worlds and open up one of these worlds. For the full world, it's the sample world, the one we've been showing. If you just double click on sample world, you might have to set a theme first, but that's like irrelevant. And it'll pull up this Webots right here.
Okay.
And then from there, you just start programming.
Wait, so I don't remember, this is a competition, so like is everyone doing the same map?
Yes. These are sample maps. The official one that's going to use that competition isn't like probably
there, yeah.
like going to be released.
Okay.
So yeah, we will like progressively add more and more test worlds. So yeah.
Okay.
Yep. And all right, I got another question. Is this for an internal competition? So it's been pre-programmed, or do students experiment with it on their own, or will there be teams? So for right now, yeah, the intention is you'll experiment with it on your own, and eventually it will be for an actual competition with kind of how the regular like Robocup Junior competitions go, if you're aware of how they work. So you form teams and things like that. All right, and finally, if you guys have any future questions that you come up with along the way, or you encounter any problems, ways you can reach out and communicate. If you go on to the page here, the stormingrobots.com/pod/dev2.html, there's a questions section. So you guys can email us with any questions or problems you guys have, including bugs you might experience, so we can get on to fixing those. In addition, for any questions about Webots in general, Webots, the simulation platform in general, not specifically about the rescue line, Webots has a pretty active Discord community that you can join. And personally, I found it pretty useful because the developers of Webots tend to get back to your questions very quickly. So if you have any general questions just about Webots, you can ask them through this Discord. All right, so I believe that's about it.
Oh, well, one more question. What level do you need to use this?
So our intention with like the release of the block programming interface was, of course, to increase like the accessibility to younger kids. So normally something like Rescue Line will be targeted at maybe early middle school level, maybe early elementary school, but mostly like early to late middle school, maybe early high school as well. So within that range, I'd say this would be targeted at, and especially since we've now added block programming, if you're not comfortable writing C++ yet, or writing text-based programming yet, then the block programming will always be an option for you. So I'd say covers a pretty wide range of skill levels.
Yeah, I can take the question. So it was, is the C coding in Webots the same as normal C in Visual Studios? Yes, it's the same C, but obviously like native C does not support motors and sensors. So Webots added some function calls for you to use. Again, if you go into the YouTube videos, you can find extra tutorials on how to program in motors and sensors inside of Webots. I do recommend that if you're gonna go into this competition and you actually want to compete seriously, we would probably recommend using C++ because like all the C syntax is basically is the same thing in C++, except C++ is a little more like up to date with their like function calls and everything. And then all of our tutorials are also in C++. So if you use C, you're gonna have to probably root through the documentation yourself. But if you do use C++, you can just follow along with our videos.
Okay, I think that it is time. This worked perfectly. And is there a class specifically for teaching Webot? Yes, there will be, and we will announce it. That will be my job. Okay, and thank you so much for all of the speakers. They did a wonderful job. As one of the person said, I agree. They did a wonderful job. So it's excellent. So do please fill out a form. So if you think that if you want another webinar for a particular topic, please do so. So then maybe we can help you out as well. Okay. All right. Thank you very much for attending. And I also have recorded this video, so I'm going to send a copy to all the people who have registered and participated. I just cannot send it to the world, to everybody, because many of you are minors, so I will have to only send it to the people who are registered. So thank you very much. Have a very good day. Take care.